Back in the 1800s, high school teachers actually were engaged in physics research, and there was a Swiss high school teacher by the name of Ørsted whose name this effect goes by. He was setting up some current for a demonstration for his students, and he noticed something very funny. What we have for you here set up is a small bar magnet. The magnet is sitting on the pivot. The south pole is the silver direction, the north pole is the black direction. We have a DC power supply sitting here. The positive current flows in the direction of the red cable, so it's flowing through this wire in this direction and then coming back around and going back into the power supply. There's a small light here that will come on when the power supply is turned on with a high enough power. So the first thing we're going to do is predict what is the direction of the magnetic field underneath this wire in the location where the current needle is. Remember, we have to use our right-hand rule to predict the direction of the magnetic field. I would like you to use the right-hand rule to make that prediction right now. I hope you were able to apply the right-hand rule in this fashion. The thumb points in the direction of the current, and our fingers curl in the direction of the magnetic field. Underneath the wire, my fingers are curling in this direction, which means the north pole is going to be pointing in this direction, so the magnetic field will look like this. Now, if I took a compass needle or a small bar magnet and I put it in a magnetic field that was pointing in that direction, I would like you to predict what the next motion will look like. I hope you've made your prediction. Now we're going to turn on the power supply and see what happens. I hope you predicted that the south pole would turn down in the direction of the magnetic field. In this case, because the magnetic field varies a lot in space, it provides a bit more friction for this compass needle, so the oscillations die off faster. But as you can see, the magnetic field is indeed pointing in this direction to get the south pole oriented in the fashion that it is. You can also see that the light is on. That's indicating that current really is flowing through the circuit. If I turn the current off, the light's going to go out and the needle is going to come back to its original direction after it oscillates a little bit, because there still is a bit of friction on the pivot in this case.